Okay, ratio of resistance and current flowing through resistors in parallel circuits. Okay, we have three problems that we are going to solve. Okay, one, two, three. Three problems that we are going to solve. The first problem, use the given figure to determine, use the given figure to determine I2, I3, and the total current. Okay, you are given this figure. You have I1. I1 is given on the figure. I1 is the current flowing through R1. I2 is the current flowing through R2. I3 is the current flowing through R3. And IT is the total current. Okay, so what is I2? Okay, I2. Let's find I2. First, you have to notice the ratio of resistance between R1 and R2 is 1:3. Okay, when you divide 3 by 3, 1, 9 by 3, 3. Okay, the ratio of resistance between R1 and R2 is 1:3. Okay, so let me show you. So from R1 to R2, you have to notice there is multiplication by 3. From 3 ohms to 9 ohms, there is multiplication by 3. Okay, there is multiplication by 3. Now, from I1 to I2, okay, from I1 to I2, you are going to have division, okay, division, division by 3, because current and resistance are inversely proportional to each other. When you have an increase in the resistance, you are going to have a decrease in the current, because current and resistance are inversely proportional to each other. So to find I2, I2 is equal to 3.6 divided by 3. Okay, and then you're going to have 1.2 amperes. Okay, now I3, you have to notice first the ratio of resistance between R1 and R3 is 1:1. Okay, 3 ohms and 3 ohms. Okay, the ratio is 1:1. When you divide 3 by 3, 1, and 3 by 3, 1. So the ratio of resistance between R1 and R3 is 1:1. So I1 is equal to I3. So I3 is equal to 3.6 amperes. Okay, 3.6 amperes. So remember, resistance is the same as opposition. So as the opposition increase, the current decrease, okay, from 3.6 to 1.2. Okay, so IT, the total current, is equal to I1 plus I2 plus I3. Okay, I1 is equal to 3.6 plus I2. I2 is equal to 1.2 plus I3. I3 is equal to 3.6. So this is equal to 3.6 plus 3.6. This is equal to 7.2 plus 1.2. You are going to have 8.4. Okay, 8.4 amperes. Now, problem number 2. Use the given figure to determine I1 and IT, the total current. So we are given I2. First, you have to notice the ratio of the resistance between R1 and R2. So let's see. from R1 to R2, the ratio of the resistance is 1:2.5. Okay, if you divide 2 by 2, 1, 5 by 2, 2.5. So the ratio is 1:2.5. So there is multiplication by 2.5. Okay, 2.5. There is multiplication by 2.5. Now from I1 to I2, because resistance and current are inversely proportional to each other, you are going to have division. Okay, division by 2.5. Okay, when resistance is increasing, the current is going to decrease. Okay, so what is I1? A value that is going to be divided by 2.5, and then you are going to get 5.6. So to get I1, you have to multiply the two values. Okay, so you have I1 is equal to 5.6 times 2.5. You are going to have 14 amperes. 14 amperes. So 14 divided by 2.5, you are going to have 5.6. Okay, now IT, the total current. IT is equal to I1 plus I2. Okay, so I1 is equal to 14 amperes plus I2, which is equal to 5.6 amperes. This is equal to 19.6 amperes. So we are done with problem number 1 and problem number 2. Now, problem number 3. Which of the following bar graphs represent the ratio of the current flowing through resistors A, B, and C in the given figure, in this figure? So A is equal to 2R, B is equal to 3R, C is equal to R. The value of the resistors is not the same. So you expect to have a different current flowing through resistors. Okay, so the current is going to be different. So bar graph A, this one, does not represent what we have. So the current through the resistors is not going to be the same. So it cannot be this. It can only be this if the value of the resistors is the same. Okay, now B. In B, you have to see that A has got the highest current. Okay, when you look at the given figure, the smallest resistor, C, is the smallest resistor. So it's going to have the highest current. Okay, C must have the highest current. Okay, so this bar graph does not represent the ratio of current flowing through the resistors. Now, bar graph C. Okay, in bar graph C, you have resistor C has got the highest current, and B has got the lowest current, and A has got the middle. So, because C is the smallest, you expect the highest current, and B is the biggest, you expect to have the least current. Okay, and A is equal to 2R. Okay, between R and 3R. So this is the correct answer, and D will be the wrong one. Okay.